In this lesson, we're going to add and subtract square roots, and again, we're going to be focused just on square roots. In this particular case, though, the radicands will not contain any variables. So this lesson, we're going to look at simplifying, at adding and subtracting square roots in which the radicands don't contain variables. Now let's review something from a previous lesson. So remember in a previous lesson, we saw that we can combine like radicals. For example, if you look at these two terms right here, see I'm adding these two terms. Now notice those are like radicals. So remember, I can combine like radicals if the index of each radical is the same. So hence we are talking about square roots. So the index here are both 2. And the radicands are the same. So in both cases, the radicand in both cases 5. So that means just like you did when you combine terms that had variables in it, you would say I have 8 of these square root of 5s plus I have another 3 of these square root of 5. So altogether, I have 11 square root of 5. Okay? And then if you look at the previous, the next one, notice these have 3 terms. Only 2 of those are like terms, though. So if you look at this particular case, the first term and the last term are alike. This term has the square root of 7 in it, which is different from these radicands. These radicands contain 2. So you can only combine these two. So if I have 6 square root of 2 and I'm subtracting 1, remember that's understood to be a 1, subtracting 1 square root of 2, I am left with 5 square root of 2 and then plus 3 square root of 7. All right. And again, addition is commutative, so if you want to rewrite this as 3 square root of 7 plus 5 square root of 2, that's fine as well. Okay? All right, so that was a review from the previous lesson, so in which we talked about what like radicals are and then how to add and subtract radicals that are alike. All right, now in this lesson, what if we had this though? What if we had let's say I wanted to add the following. I had the square root of 50 and I wanted to add the square root of 8. Let's say I had that. All right, the way it looks like they're not like radicals, right? So, the index are the same. They're both 2's. We're dealing with square roots. But the radicand here is 50 and the radicand here is 8. So you may say, well, I can't combine those. Those are not like radicals. Yeah, but remember, in a previous lesson, in one of our lessons prior to this, we talked about simplifying radicals. And so if you remember, you need to ask yourself, can I simplify the square root of 50? Can I simplify the square root of 8? So the way it looks, yeah, you're right, the radicands are not the same. But are they still like radicals? Can I simplify this to make it look like they are like radicals? So the first thing you have to do is, before you add and subtract square roots or cube roots or whatever root you're dealing with, you need to make sure that you simplify the radicals. So if you look at the previous lesson that we did, these radicals here, I couldn't simplify any further because if you look at the radicand 5, the radicand 2, the radicand 7, the only perfect square, remember we're dealing with square roots, so the perfect square comes back into play. The only perfect square that goes into these radicands is 1. Here, though, that's not the case. So let's think about the square root of 50. What's the largest perfect square that goes into 50? Well, 25. So that means I can rewrite this as the square root of 25 times 2, right? And then let's think about the square root of 8. So the square root of 8, that will be the square root of 4 times 2. So 4 is the largest perfect square that goes into 8. And so remember the product rule. So the product rule then says I can rewrite this now as the square root of 25 times the square root of 2 plus the square root of 4 times the square root of 2. And then the square root of 25, since 25 is a perfect square, the square root of 25 is 5, so you get 5 square root of 2. And then over here, the square root of 4 is 2, so I get 2 square root of 2. And now notice those are like radicals. Those are like terms. So therefore, I can combine those. So 5 plus 2 would be 7, so the answer is 7 square root of 2. Okay? All right, so that's what you would do. So that's your work right here. So this is the work that you would show to get to this point. All right, so let's call this number 1. And then the directions will usually say something like add or subtract. So there's going to be a mixture of these. I'm just going to say add or subtract as indicated. So let's look at number 2. So number 2, let's suppose we had the square root of 27 minus the square root of 12. All right, now I want to subtract those. Now remember, I can't subtract those just yet because the radicands are different. But then you got to remember, can I simplify? Can I simplify the radicals? And we are dealing with square roots only, so just think about perfect squares. Just think about your perfect squares. All right, let me see if I can find the list with perfect squares that we talked about in the previous lesson. Okay, so remember in previous lessons we talked about perfect squares, and in one of our lessons we talked about perfect cubes. But we only deal with perfect squares here because we're only dealing with square roots. So if you look at 27, is besides 1, which of these perfect squares, and we want to choose the largest if possible, will divide into 27 evenly? Okay, 9, right? And then for 12, which one will it be? Well, it'll be 4. All right, so that means I'm going to rewrite this as the square root of 9 times 3 minus the square root of 4 times 3, right? Because 9 times 3 is 27, 4 times 3 is 27, and 9 and 4 are perfect squares. Now I'm going to use the product rule. So remember, we're talking about the product rule. So the product rule, and so the product rule says that if I have in this case I'm going to use the word square root. So I've got the square root of a product, then I can rewrite this as the product of the square root of each factor. So the square root of 9 times the square root of 3 minus the square root of 4 times the square root of 3. And then I can simplify each of those square roots. I can simplify the square roots I can simplify. So the square root of 9, since 9 is a perfect square, the square root of 9 is 3. The only factor, I cannot simplify the square root of 3 because the only perfect square that goes into 3 is 1. So I'm just going to rewrite this as 3 times the square root of 3 minus, and this will be 2 times the square root of 3. And so therefore I can combine those. So those are now written as like terms. So 3 square root of 3 minus 2 square root of 3 is 1 square root of 3. So just write it as square root of 3 though. All right, so that's number 2. Number 3, let's suppose we have this in number 3. We have, all right, this will be number 3. We have the square root of 48 plus the square root of 147. All right, so the square root of 48 plus the square root of 147. So use your calculator if you need to try and help you determine the largest perfect square. So let's think about 48. So if you go down the list of perfect squares, like we did in previous lessons, remember 1 goes into every number, so we're not even going to look at that. But let's look at 4. So if I do 48, take 48 divided by 4, I get 12, right? All right, so in my mind, I know that 48 is 4 times 12, but 4 is not the largest. And remember, 4 is not the largest because if I look at 12, there's still one of these perfect squares that goes into 12 evenly besides 1, 4 again. So this becomes this 4, and then 12 is 4 times 3. And you see I have this product right here that are perfect squares. So that means 4 times 4. So this is a perfect square times another perfect square. So the product is going to be a perfect square. So that means that 16 is going to be the largest because 3, the only perfect square that goes into 3 is 1. And so I'm going to rewrite this as 16. So I get the square root of 16 times 3 plus, all right, let's look at 147. Now, I'm going to say this. Chances are, you see how I got that 3 right here that I cannot rewrite another way because the largest perfect square is 1. Chances are I'm going to have a 3 right here as well. So what I would do is this, because that's not a number less than 100. So what I would do is I would take 147 and I would divide it by 3 and see what I get. And I get a perfect square of 49. All right, so then I'm going to rewrite this as a square root of 49 times 3. Usually in these problems when they ask you to add or subtract radicals, at least one of the terms you're going to be able to, two of the terms will be like terms, most chances are. And so if I have a square root of 3 here, then I'm going to need a square root of 3 here. So I would just check and see if this is divisible by 3. And so now I'm going to use a product rule. And so the product rule says that I'm going to rewrite this as the square root of 16 times the square root of 3 plus the square root of 49 times the square root of 3. And so the square root of 16 is a perfect square, so the square root of 16 is 4. So you have 4 square root of 3 plus, and then the square root of 49 is 7 square root of 3. And now I can combine those. So when I combine those, 4 plus 7 is 11, so I get 11 square root of 3. And so that's your answer. Okay? All right, let's look at number 4. Number 4, I have this problem. All right, so let's do number 4. Okay, so number 4, we have 5 square root of 27 minus the square root of 3. 5 square root of 27 minus the square root of 3. All right, so notice that I cannot simplify the square root of 3 because the only perfect square that goes into 3 is 1. But I can simplify the square root of 27. And in fact, we all know that the largest perfect square is going to be 9. So I'm going to rewrite this as 5 times the square root of 9 times 3, right? And then minus square root of 3. So the only radical I can simplify will be this one. I cannot simplify this any further. So now I'm going to use a product rule here. So I'm going to get 5 times the square root of 9 times the square root of 3 minus the square root of 3. And then the square root of 9 I can simplify now because that's going to be 3. So I get 5 times 3 times the square root of 3 minus the square root of 3. And then 5 times 3 is 15. So I get 15 square root of 3 minus square root of 3. And now those are like terms. So 15 subtract 1 is 14. So I get 14 square root of 3. All right. Very simple, right? Not difficult. Number 5, we have 4 square root of 32 minus 8 square root of 18. All right, so let's suppose we had that. Okay, so again, it looks like I can simplify both of those. So what's the largest perfect square that goes into 16? Now again, you may say 4, right? All right, let's think about this. All right, so be careful. Always use the largest. Remember in one of our lessons in the past, if we don't use the largest, you end up with a lot of steps. So always try using the largest. So if you say 32 divided by 4, you're going to see that 4 is not the largest. Watch. Because when you divide it by 4, you get 8. But what other perfect square goes into 8? 4. So 8 is 4 times 2. So that 4 times that 4 is 16. So you're going to get 4 times the square root of 16 times 2, right? And then minus 8. And then for 18, you see this 2 right here? I would just check and see if I divide 18 by this 2, since 2, the only perfect square that goes into 2 is 1, and then see if I get a perfect square. 18 divided by 2 is 9, so I get a perfect square of 9. So I'm going to rewrite this as the square root of 9 times 2. So now I'm going to use a product rule on these, just like I did here. So I'm going to get 4 times the square root of 16 times the square root of 2, minus 8 square root of 9 times the square root of 2. And I'm going to simplify these square roots because those are now perfect squares. I cannot simplify the square root of 2 because the only perfect square that goes into the radicand is 1. So I get 4 times 4 square root of 2 minus 8 times 3 times the square root of 2, right? So these are all, see these three factors? 4 times square root of 2, 8 times 3 times square root of 2. But I know what 4 times 4 is. 4 times 4 is 16, so I get 16 square root of 2 here. I know what 8 times 3 is. 8 times 3 is 24, so I get 24 square root of 2 here. And so 16 square root of 2's minus 24 square root of 2, since those are like terms now, like radicals, they have the same index and the same radicand, then that's going to be a negative, what's that, 8 square root of 2? So that's the answer. All right? Okay, let's go to number 6. So number 6, we have the square root of 32 minus the square root of 50 plus the square root of 2. So I'm looking at 3 radicals here, 3 terms. So let's see if I can simplify those. So I cannot combine them right away because they all have different radicands. So remember, the first thing you always do is simplify. Simplify first. Simplify first. Okay. So if you look at the square root of 32, that's going to be just like we just did a while ago. So that'll be 16. So I get the square root of 16 times 2. Square root of 50, the largest perfect square that goes into 50 is 25. So it'll be the square root of 25 times 2. I cannot simplify this because the only perfect square that goes into 2 is 1. So I'm going to leave it as square root of 2. And I'm going to use a product rule. So now I'm going to say this. Many students at this point, they'll just look at this and say, all right, so they'll go from here to this. They'll say the square root of 16 is 4, so they'll say 4 square root of 2. Minus the square root of 25 is 5, so let's say 5 square root of 2. And then plus square root of 2. But you got to be careful because I have seen students that write it backwards. They'll say 2 square root of 4. So you have to be careful when you skip that step. Okay, so you see I skipped that step. So if you need to rewrite that step, if you mess up at this point because you're skipping a step, then go back and rewrite it. So by rewriting, I'm talking about using the product rule. So this becomes the square root of 16 times the square root of 2 minus the square root of 25 times the square root of 2 plus the square root of 2. And now notice that I can simplify these, and that's what you see here. Okay? So if you mess up when you go from here to here by skipping that step, then I would suggest that you actually write it out. All right, so now these are all like terms because they all have square root of 2's. So I have 4 minus 5 is a negative 1, right? So this right here, remember you add and subtract from left to right. So this is a negative 1 square root of 2 plus the square root of 2. But what's a negative 1 plus 1? 0. So the answer is just 0. All right, so that's 0 there. Okay, number 7. You have, let's say we have negative 7 square root of 18 plus 8 square root of 32 minus 2 square root of 8 plus 2 square root of 2. So this time we have 4 terms, 1, 2, 3, 4. And so it looks like I can simplify this one, and this one. So because the radicand 2 here, the only perfect square that goes into 2 is 1. So let's look at 18. What's the largest perfect square that goes into 18? 9. So I'm going to rewrite this as negative 7 times the square root of 9 times 2 plus 8 times the square root of, and the largest perfect square that goes into 32 is 16, so it'll be 16 times 2 minus 2 times the square root of, and the largest perfect square that goes into 8 is 4, so it'll be 4 times 2 plus 2 square root of 2. I cannot simplify this one, so I'm just rewriting it. Now I'm going to use the product rule. So now it's a good idea here with all these numbers in front, the coefficients in front of that square root, to actually show the product rule being used. So this is 7 times the square root of 9 times the square root of 2, right? Over here, plus, this is 8 times the square root of 16 times the square root of 2, minus, this will be 2 times the square root of 4 times the square root of 2, and then plus 2 square root of 2. Okay? Now let's go ahead and simplify this. So this becomes 7 times the square root of 9 we know is 3 times the square root of 2 plus 8 times the square root of 16 is 4 times the square root of 2 minus 2 times the square root of 4 is 2 times the square root of 2 and then plus 2 square root of 2. Okay, so all I did was I simplified each of those radicals that you see there. And now we know 7 times 3 is 21, so this right here simplifies to 21 square root of 2 plus this term here. When I put those factors, that product becomes 32 square root of 2. 8 times 4 is 32. Here, 2 times 2 is 4, so it'll be 4 square root of 2, and then plus 2 square root of 2. Okay? All right, now, again, you have four radicals. Those are all now like terms, right? They're all like terms, so then I can add from left to right. So if you look at the first one, and you can go directly to your calculator, but let me just show you something. So if you look at the first two, 21 square root of 2 plus 32 square root of 2 will give you, what's that, 53 square root of 2? So 21 plus 32 is 53. And then you have minus 4 square root of 2 plus 2 square root of 2, right? And then if you look at this, 53 square root of 2 minus 4 square root of 2, well, that's 49 square root of 2 plus 2 square root of 2. And so your final answer then would be 49 plus 2 is 51 square root of 2. But you didn't have to go through all this step. Once you get to this point, once you get to that point, you can use your calculator. And so you just look at the coefficients. So I have a 21, so you're going to say 21 plus 32. See that? and then minus 4, so minus 4, and then plus 2, and you get 51. So then you just go from here to the answer. Okay? All right, so that's number 7. Okay, let's look at number 8. So number 8, we have this problem for number 8. All right, so let's say we had the square root of 36 minus the square root of 48 minus 4 square root of 3 minus square root of 9. Okay, so if you look at this right here, this first radical, it's a perfect square. So really there's no work there. I know the square root of 36 is square root of 36. It's 6. Now 48 is not a perfect square, but what's the largest perfect square that goes into 48? All right, well you may say 16. Okay, so 48, use your calculator. 48 divided by 16 should be 3, right? So 48 divided by 16 gives us 3. So we're going to say minus the square root of 16 times 3. Minus, I cannot simplify this because 3, the radicand 3, 1's the only perfect square that goes into 3. So I cannot simplify that. And then here, the square root of 9, that's just 3. So then I'm going to rewrite this as 6 minus, and then use a product rule. Square root of 16 times square root of 3 minus 4 square root of 3 minus 3. So the only thing I can simplify at this point is this one. This radical here is this one. So square root of 16 is 4. So look at what we have. 6 minus 4 square root of 3 minus 4 square root of 3 minus 3. All right, now let's talk about this. So in terms of each term, I've simplified each term by itself. Now let's look at like terms. So do y'all agree that I can combine a 6 and then I can take the 6 and subtract 3, right? So those are like terms. So 6 subtract 3 is 3, right? So that becomes 3. Now if you look at these two, those are like terms. Okay, so remember, look at the coefficients of the radical. So a negative 4, and then I have another negative 4. So it's a negative 4 and a negative 4, negative 8. So don't say that's 0, because those are not opposites. Those are the same terms. So a negative 4 and a negative 4 is a negative 8. So I get 3 minus 8 square root of 3, and that's your answer. Okay, now if you want to rewrite it, you can put the radical first. You can say negative 8 square root of 3 plus 3. Either one of those is fine. All right, so it's number 8. Number 9, we have the square root of 80 plus 3 square root of 125. The square root of 80 plus 3 square root of 125. All right, so if I look at that, the largest perfect square that goes into 80, let's try... So if you look at your perfect squares, let me go ahead and get that out. So remember, you really need to go halfway of 80. So halfway of 80 is 40. So we just need to try up to 36, right? So if I look at 9, well, we know 4 goes in 80, so let's just check 9. Well, let's do that. Let's do 80 divided by 4. So if you look at 80 divided by 4, do you see that there's another perfect square that goes into 20? What other perfect square goes into 20? 4. So 4 times 4 is 16. All right, so now we know if you think about this, let me go and do it here. So we think about 80, so we know that 80 is 4 times 20, right? And then I know I can rewrite 20 as 4 times 5, and so then this product will be your largest perfect square, so 16. So this will be the square root of 16 times 5 plus 3. Now you see how we had a 5 here? Let's see if I divide by 5, if what I end up with is a perfect square. So 125 divided by 5 gives us 25, and so that's going to be our perfect square that we're going to use. So plus 3 times the square root of 25 times 5. All right, see the 5s right here? So that's what's going to help us get this to be look like terms. So this becomes a product rule. I get square root of 16 times square root of 5 plus 3 times, and then product rule here, the square root of 25 times the square root of 5. And so I'm going to get the square root of 16 is 4, so I get 4 square root of 5 plus 3 times 5, right? Times the square root of 5. Now let's go ahead and deal with this part here. 3 times 5, 15, so I get 4 square root of 5 plus 15 square root of 5, and now I can combine those. So the answer is going to be 4 plus 15 is 19, so it's 19 square root of 5s. Okay? All right, let's look at number 10. Number 10, this time let's look at this. I have the square root of 3 divided by 64 minus the square root of 3 divided by 49. Okay, so don't let that throw you off. Notice though, I am going to have to use the quotient rule this time. So the quotient rule. And so remember, the quotient rule says that I can rewrite the square root of a quotient. And remember, when we talk about quotient, we're looking at fractions, division. So that'll be the square root of 3 divided by the square root of 64 minus the square root of 3 divided by square root of 49, right? And so this becomes, I'm going to go ahead and do it this way. This becomes the square root of 3 divided by 8, because 64 is a perfect square, minus the square root of 3 divided by 7, because 49 is a perfect square. The square root of 49 is 7. Now if you look at the radicals, those are like terms. So at some point, I can combine these two. I just have to find the least common denominator. All right, so I'm subtracting these two fractions, and those are like terms because they both contain square root of 3's. Okay, I just need to remember how to add and subtract fractions. So we got to find the LCD. So the LCD of 8 and 7 is 56. And so I'm going to write two fractions with 56 as the denominator. And so remember what we did, we asked ourselves 8 times what is 56? Well, 7. So if I multiply the denominator by 7, I got to multiply the numerator by 7. And so square root of 3 times 7 will be 7 square root of 3. Don't say 21. We talked about that before. See, that's not the square root of 7. That's just 7. So, and that's not 3. That's the square root of 3. So you can't just say square root of 3 times 7 is square root of 21. That's not true. It's 7 times the square root of 3. And over here, I'm going to multiply this by 8 to get 56. 7 times 8, 56. I'm writing equivalent fraction. Remember, those are called equivalent fractions. This fraction is equivalent to this. The square root of 3 divided by 7 is going to be equivalent to, again, multiply the numerator by 8 to be equivalent to 8 square root of 3. And now I can combine. So what's 7 square root of 3 minus 8 square root of 3? That's a negative 1 square root of 3, right? And my denominator is 56. But we prefer, remember, if it's just negative 1 square root of 3, just write it as negative square root of 3 divided by 56. And so that's it. So you got to remember some things. Sometimes what you learned a long time ago still applies. So in this case, finding LCD and adding and subtracting fractions. All right, so that was number 10. Let's look at number 11. So it's not that bad. Just knowing things you've had in previous lessons will help you with the new lesson. So it's not a difficult topic. Okay, number 11, let's suppose we had this for number 11. We have 2 fifths square root of 50, minus 3 sevenths square root of 245. All right, so don't let that throw you off. Let's just deal with it, see what happens. So the square root of 50, I know that I can simplify the square root of 50. So that's going to be 25 times 2. So if you want to go off to the side because those fractions kind of scare you, then just go off to the side and then simplify that. So the square root of 50 will be the square root of 25 times 2, right? And so that using a product rule, that's the square root of 25 times the square root of 2. So that's 5. Square root of 25 is 5. Square root of 2. So now this, I'm going to rewrite this square root of 50 using this now. So this becomes 2 fifths times 5 square root of 5, right? I'm sorry, square root of 2, excuse me. I'm in 2 here. 2. Okay? And then let's do square root of 245. Now you see how, let me make sure that's, okay. Now let's do square root of 245. Square root of 245. All right, so see how the last digit is 5? Let's go ahead and divide by 5 and see what we get. I know that 5 is not a perfect square, but let's just do that. So 245 divided by 5 equals 49. And so notice that when I divided by 5, although I knew that 45 wasn't a perfect square, I ended up with a perfect square. So it'll be 49. So 245, square root of 245 will be the square root of will be 49 times 5. And so that'll be the square root of 49 times the square root of 5. And so that will be 7 square root of 5, right? Okay. All right, so that's going to go here. So minus 3 sevenths times 7 square root of 5. Okay. Now I want you to notice something. Let me go ahead and rewrite this over so I don't mess up this little part. So 5 square root of 2 minus 3 sevenths times 7 square root of 5. If you just look at this part here, okay, this part. Remember, you can reduce, right? So I can reduce a 5. So notice that the 5's divide out, and so you get 2 times 1 is 2. So this is 2 square root of 2, right? 2 square root of 2. Okay, and then minus. All right, and do the same thing here. So if I cover this part right here, the 7's divide out, and so you get 3 times 1 square root of 5 is 3 square root of 5. All agree? And then notice I can't, those are not like terms, so I'm done. I've simplified. The only perfect square that goes into 2 is 1. The only perfect square that goes into 5 is 1. So there's your answer. Okay, that's it. Those are not like terms, so you can't go any further. You can't combine them. All right, so that's number 11. And then finally, let's look at number 12. So this will be the last one, and I think you should have enough information to be able to deal with this topic. So 1/4 times the square root of 32 plus 1/7 times the square root of 98. All right. So again, see, like we did here, let's go off to the side and kind of do some of our work. So the square root of 32 is the square root of 16 times 2. So 16 is the largest perfect square. The product rule says I can rewrite this as square root of 16 times the square root of 2. The square root of 16 is 4, so you get 4 square root of 2. So that's going to go here. So that's 1/4 times 4 square root of 2 plus 1/7. Well, let me go ahead and deal with the square root of 98. So the square root of 98. So let's try. What I want to do is see how that was a 2 here, and this is even. Let's see what happens when I divide by 2. So I know 2 is not a perfect square. Let's just do that. See what happens. I get 49, and 49 is a perfect square. So right away, I know what the largest perfect square is. So it'll be the square root of 49 times 2. And that would be the square root of 49 times the square root of 2 using the product rule. And so that becomes square root of 49 is 7. So this is 7 square root of 2. All right, so that's going to go here. Times 7 square root of 2. Okay. Now let me go ahead and rewrite this over so I can kind of like the same thing I did here. 4 square root of 2 plus 1/7 times 7 square root of 2. So if you need to cover some stuff up, then cover some stuff up. So if you look at this part here, just this little part, this term, the 4's divide out, right? So the 4's divide out, and so you get 1 times 1 square root of 2 is square root of 2 plus, and then over here the 7's divide out. You get factors of 1 in their place. You get 1 times 1 square root of 2 is square root of 2. And now, see how I could not combine these? But can I combine these? Yeah. So what's square root of 2 plus square root of 2? 1 plus 1 is what? 2. So it's 2 square root of 2. So that's your answer. Okay? So this is going to be the end of this lesson, and I think you should be okay with this now. So remember, this was a lesson where we simplified, well, we added and subtracted square roots, but we had to simplify the radicals first and then combine like radicals. All right, so that was the end of this lesson.